Okay. This is sort of the start of the last official chapter of the course. The course is going to look quite different this semester if we don't go back to school, because the culminating will have to change in a way. So I'm sort of working on some ideas of how we can do a culminating that makes sense. They've already canceled exams, so we can't have an exam, but we can replace it with something that's worth value. So without us having to do the culminating, which normally chews up at least 3 weeks of the semester between the computer lab and presentations, we find ourselves with quite a bit of time. So you'll notice that I've spread out the lessons so that we just do 2 a week. The weather's getting nicer. We've been in our houses for 8 or 9 weeks now. I can't even remember. So school's coming to an end, and for you guys that are in grade 12 and are moving on, hopefully this transition won't be as bad as it had to be. So we do have 6 lessons in chapter 5. So the first 2 we're going to get through the week of, in theory, the week of May 11th to 15th. And then we'll do 2 a week, which brings us to a date of June 3rd and June 4th to have our assignment. And I'm going to do the quiz and assignment both in the same 2-day period. The quiz will just be the multiple choice section, and then the assignment written as normal. But we'll do them together so that we get through the whole unit. Okay, Pascal's triangle. If you took 11U, you've definitely already looked at Pascal's triangle. So Pascal's triangle is a triangle that in grade 11 when you learned about it, you were like, what on earth are we learning this for? It was kind of like this topic that got thrown in at the last minute and didn't have anything to do with anything else other than in series and sequences we saw patterns, and Pascal triangle had patterns, but it didn't really have a huge link. Well, in data management we see a whole other side to the applications of Pascal's triangle. And so I'm going to refresh your memory about Pascal's triangle in 5.1, and then in 5.2 we're going to apply it to something that deals with this course. Okay, so Pascal's triangle looks like this. It's shaped like a triangle, which makes sense. The bordering numbers are all 1s. So on either side of these diagonals, they all start with 1. So what happens is when you look at it, this is a row, then this is a row, 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 row. These are called diagonals. So I've kind of put this light blue line in between. Diagonal, 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 diagonal. You just keep going, right? Like as it goes, you have more and more diagonals. Now, this is not the end of Pascal's triangle. Pascal's triangle is infinite. And you'll see what I mean when we start looking at the patterns within it. The important thing that we want to wrap our head around right now is that the rows don't go in the order you would expect. So we don't call this the first row and then the second row. We all actually call this the 0th row. And then the first, second, third. They all continue successively after that. And what you'll notice is one sort of nice thing that happens is in the second row, remember they all start with 1, but in the second row, the second term is a 2. In the third row, the second term is a 3. In the fourth row, it's a 4. The fifth row, it's a 5. So it actually is a nice pattern. With the diagonals, the same idea. This is called the 0th diagonal, and then they go first, second, third, fourth. Now, these are the actual numbers of Pascal's triangle. We want to start referring to them as terms. So we're going to put 2 numbers in the subscript next to the T. So this script T stands for term. And then there should be 2 numbers beside them. The first number is going to represent the row that it's in. So this is the 0th row, starts with a 0. In the first row, they both start with a 1. In the second row, they all start with a 2. In the third row, they all start with a 3. The second number is going to be the diagonal you're in. So remember, this first diagonal is called the 0th diagonal, 0, 0, 0, 0. The first diagonal, 1, 1, 1. Second diagonal, 2, 2. Third diagonal, 3, so on and so forth. So if you look, every row should start with the same number, but the second number will continue to increase by 1 as you go into the next diagonal, the next diagonal, the next diagonal. Okay, so this is called the term. Okay, and no matter what the term is, it can be any numbers here. The first number that appears will be the row number. The second number will be the diagonal number. And we use N and R, so we're always kind of referring to our rows with N's, and as you go across, our diagonals are referred to as R's. Okay, so be aware, N is your row number, R is your diagonal number. Okay, it's a lot to sort of digest. I'm not sure what's in the 11M curriculum, so I don't know if you've been introduced to Pascal's triangle or not. So if you need to take a screenshot of this, but this is all sort of inside. Your note looks like this if you printed off the one that's filled in. It'll start making more, the filled in version will make more sense as I go through this. Okay. Now, what we want to look for are specific patterns within Pascal's triangle. So the first pattern, I'm going to rewrite Pascal's triangle. I probably shouldn't have erased that. I'm going to rewrite the first couple rows of Pascal's triangle. So it starts with a 1 and then a 1 and a 1. This is the triangle on the top where they're all 1s. And then some of you are saying, well, how do you have this memorized? How do you know what comes next? And if I told you I could go on forever, I could. I have zero doubt that I could continue drawing Pascal's triangle forever. And the reason is because there are patterns built within it. So the first pattern is called Pascal's formula. Okay, and this is the one that we're going to use the most. And I don't want to get my leg in the way here for you guys to see. And Pascal's formula looks like this. To find term NR, come on in, guys. No, this is my second board. It's okay. You're going up to read? Where are you going, Word? I can't turn the heater on because it makes too much noise for my video. You can go under the blanket? Do you want a blanket up there? Do you want a blanket up there?
Yes.
1 minute. Morgan, you coming up here? Or are you going over the entry? Here.
What's she doing?
I don't know. You just can't make noise, okay?
I know it. I'm going to turn it all the way down.
Here, come here. I don't want this to take forever. Here. Get in.
Mommy. Take a second.
No, it's my first video, but it's my second screen. Hurry up. We're wasting time. Okay. Good? Okay, so Pascal's formula, is going to look like this. Term NR is going to be term n minus 1, r minus 1, plus term n minus 1r. And you're saying, what the heck are you talking about? Okay, this looks very confusing. But basically what this is saying is if I want to find the term in the nth row and the rth diagonal, I have to look to the n minus first row. Well, n minus 1 is 1 row before the nth row. Okay, so you're really looking to the row above it. So for instance, if I want to find this value, okay, so right now this value, you would look and you'd say, that's the 0th row, 1st, 2nd, 3rd, 4th, 5th. So this is the 5th row, 0th diagonal, 1st diagonal, 2nd diagonal. So that is the 5th row, 2nd diagonal. That's what term number that is. If I want to find that value, I have to, so now I know my n is 5, my r is 2, right? I picked this is a random example. My n is 5, my r is 2. Well, I want, in order for me to figure out what that is, I have to go to the row above it, n minus 1. So n is 5, 5 minus 1 is 4. R minus 1, r is 2, 2 minus 1 is 1. And add that to 4, 2. So then I look and I say, well, where are those terms? Where is term 4, 1? This is term 4, 1. This is term 4, 2, right? This is the 4th row, 1st diagonal, 4th row, 2nd diagonal. And what it says is if we add those two terms up, 4 plus 6, we will get the term right below it, which is a 10. Okay, and this is how you build all of Pascal's triangle. You always take the two terms above, and when you add them, they will be the term below. You take the two terms above, and when you add it, it'll be the term below. Okay? So that is what the pattern is, and that's how you can build more of Pascal's triangle. If I wanted to go here, I would say, always starts with a 1, add the two terms together, that gets the one below. Add the two terms together, that gets the one below. Add it, add it, Okay, so that's why I'm confident saying, well, I can build Pascal's triangle forever, because as long as I can add, I can continuously build it. It always has a 1 at the beginning, it always has a 1 at the end, and then you just add the ones above it to get the one that goes below. Okay, so in formula form, it looks a little bit tricky, but it shouldn't really matter. And I gave a couple examples on the sheet. I said, well, if I had the 121st row and the 57th item, how would I find it? Well, you'd have to go to the row above 121, so the 120th row. And then let's look at the pattern of where you'd have to get it from. So in this one, I went to the second diagonal. I had to add from the first diagonal and the second diagonal. So these matched. Okay, so if I'm going to the 57th diagonal, this is going to be a 57. This is actually going to be the previous term, because you're going to go backwards into the diagonal before. So this is going to be, if I know term 120.56 and I know term 120.57, I can figure out 121.57. And it really doesn't matter. If I go to the 1001st row and the 913th diagonal, I go to the row above it. So the row above 1001 is 1000. And then again, this is 913, so is the second term. The other one is going to be the one before it, 912. Okay, so it's a fairly easy thing to look at once you've done it a bunch of times. Okay, so that's the first pattern. The second pattern is about the sums of the rows. So if I just add up everything in a single row, so this one is a 1. This one, 1 plus 1 is 2. This one, 1 plus 2 plus 1 is 4. 1 plus 3 plus 3 plus 1, 8. So I'm just adding up each value in a row. 1 plus 4 plus 6 plus 4 plus 1 is 16. And what you'll start to notice as you go across and you're adding them all up is, what do these numbers have in common? 1, 2, 4, 8, 16, 32. You look at them and realize they're all base 2 numbers. If I just keep multiplying by 2, I get the next one. Multiply by 2, multiply by 2, multiply by 2, multiply by 2. And what that's representative of is exponents. So 1 is actually the number 2 to the power of 0, you may remember from grade 11. 2 is the number 2 to the 1. 2 squared, 2 cubed, 2 fourth, 2 to the fifth, so on and so on. And this is the sum rule. So the sum rule is basically this. The sum of all terms in the row number, so we're going to call it the nth row, is 2 to the exponent n. Okay, so in the 5th row, it's 2 to the 5. In the 6th row, it would be 2 to the 6. In the 20th row, it would be 2 to the 20. Okay, so that's called the sum rule. So again, all of these rules are kind of listed in the note. You can see them all worked out in the same sort of way. So if it seems like it's going a little fast in here, you should sort of be following along. Okay, the next one they said, the next rule is that the outer diagonals are always 1s. We've already talked about that. Number 4 is that it's symmetrical. And what do I mean by that? I mean, if I draw a line right down the middle, then it should be exactly the same on either side. Ooh, a 3 and a 3, 4 and a 4, 5 and a 10 and a 5, 7, 21, 35, 35, 21, 7. It's like a mirror, right? So that's called the symmetrical property of Pascal's triangle. Okay, there are now a couple examples that we'll go through, and then that's really the basics of what you need to know about Pascal's triangle before we move forward with 5.2. Okay, so, whoops. A couple examples are going to look like this. Okay, and the first one is just basically saying the first 6 terms in the 25th row of Pascal's triangle are 1, 25, 300, 2300, so purposefully picked a really large row in Pascal's triangle. Determine the first 5 terms of row 26. So imagine this is the 25th row. we now want to find the 26th row. What you're applying here is the idea that if these were all in the row above, to find the row below, you use the Pascal's property that says you simply add them. So we know it has to start with a 1. And then you add the two terms to find the one below. So 1 plus 25, the next term here would be 26. 25 plus 300, 325. So you're just using that property, 2600, add them, 14,950, and then 65,780 when you add those two. So it's just a matter of applying. We don't have the whole triangle set up, but it's still using the same idea. If this was going to be part of the triangle, it would start with a 1 and then go from there. Many people forget about the 1 and they'll just start adding right away. But remember, the first term always has to be a 1. Okay, the second example, in a similar manner, they're saying, use Pascal's method to write a formula for each of the following. So this was B. We want to find, how can we find term 12.5? How can we find term 45.7? How can we find term n plus 1, r plus 1? And we're going to use the same pattern for all of these. In order to get something from the 12th row, you have to add things from the row above it, which means we have to go back up to the 11th row. And then which diagonals do we have to go from? The second one is going to be the same. So this was the 5th diagonal, that'll be the 5th diagonal, and then the one before it. So the 4th diagonal. That's the pattern. That's the easiest way to do it. If I want to find something in the 45th row, I have to go to the row above it, the 44th row. To find which diagonal, I'm going to keep the same diagonal for my second term and go one diagonal before the 6th one. Okay? Not difficult. If I want to find something in the n plus 1 row, I have to go one before it. So what's 1 before n plus 1? Just n. Picture subtracting 1 from this. You have n plus 1 and you subtract 1, you're just left with n. Same way with when you had 45, you subtracted 1 and got 44. Or you had 12, you subtracted 1, you got 11. Okay? So we know we have to go to the nth row. Diagonal, keep the same for the second term, r plus 1. And what is 1 less than r plus 1? R plus 1 minus 1. You subtract 1 and you just get r. Okay, so it's a little bit of a pattern. You'll see questions like this pop up maybe in the multiple choice when we get to doing the quiz. But you should know things about Pascal's property. Okay, example 2, which is the last one, and this is a really quick note again, is talking about the sum. So the first one says find the sum of the 12th row. And it's very straightforward. The sum of the nth row is 2 to the n. So if we're looking for the sum of the 12th row, it'll be 2 to the 12, which when you get a calculator, you can just do 2 to the exponent 12 and get a number. Okay? B says, which row of Pascal's triangle has a sum that equals, so this one says, if the sum is equal to 32,768, then what row number is it? Okay, so you're basically saying 2 to some value up here, and we don't know what it is, we'll call it n, is going to be equivalent to 32,768. Now, if you've taken advanced functions, you'll happily use logarithms. If you haven't, it's just a matter of basically guessing. So you're going to take your calculator and keep guessing different exponents until you get 32,768. So here, I'll just 2 to the 12 is we just found 2 to the 12 to be 4,096. Clearly larger. So you're like, okay, maybe it's just 2 to the 13. 8,192. Not big enough. Let's go a little bit higher. 2 to the 15. 2 to the 15 is exactly 32,768. So we know that n equals 15. So we're talking about the 15th row would get us a sum of 32,768. Again, if you know about logarithms, use them. If you don't, just do trial and error. Okay, so this is the basics. There's very little homework associated with this, a couple questions. It's coming from 3 different pages, but we need to have a general understanding of Pascal's triangle before we can get into what we're using Pascal's triangle for, which is going to come in 5.2. Okay? All right, how's the reading going, Ben?
Good.
Good? Okay.
Page 15.
Page 15. Oh, nice.